All right, guys. So we're going to go on and get started with the lesson today. Now, one of the biggest things I would say is making sure that we get this here because there isn't a whole lot to it, especially some of these parts. But if you miss one of the main parts to it, it's going to be confusing. So this is the first thing we're looking at. Now, we talked about exponential functions yesterday. Today we're going to be talking about logarithmic functions or logarithms. Now, incidentally, logarithms and exponentials are inverses of each other. They're inverse functions. And the first thing we're looking at is this here, log base b of y equals x, if and only if b to the x is equal to y. So we can go from one to the other. So if we look at these first few here, using this property, log base b of x is equal to y, if and only if b to the y is equal to x. We have this here. So looking at the first one here, we have log base 2 of 16 is equal to 4. So here, our b is being represented by what number? 2. X is 16 because it's inside, and y is 4. So if I want to rewrite this as a log or an exponential, we would say is equal to. And on some of them, I've switched the x and y. The one I wrote on the whiteboard, I did flip the x and y position, but they still work the same because y is inside on the whiteboard equals. It's just x and y flipped. It is the same thing because if you notice, x is on the inside for the one I wrote on the smart TV. X is on the outside here, but they do change to their corresponding locations, if that makes sense. Now the next one, well, actually before we go to the next one, 2 to the 4th equals 16 is what we have, yes? Now with these here, since they're all just numbers, we can actually check this. So in a calculator, I can say 2 to the 4th is 16. So it does give us a true statement. It is true. Now for the next one, our base is log base 4. So our base would be 4 to the 0 is equal to 1. Questions on this here? And again, with this one here, we could check it and say 4 to the 0 and see that it is indeed 1. Questions on either one of these here? Let's look at the next one. Log base 12 of 12 is equal to 1. 12 to the first is equal to 12. How about the next one? And I mean, we could check both of these here. So we can say parentheses 1/4 to the negative 1 is indeed 4. Because if it's negative, we flip it, changing it from 1/4 to 4 over 1, and we have it simplified.
So then this would be cubed equals 16.
The next one would be log base 7 of 1 is 0, would be
7 to
log base 21 of 21 is equal to 1. One-fifth to the negative 1 is equal to 5. Questions on any of these here? Now, we're going the other way. Because we said log base b of x or y is equal to x. I'm going to make it the same as the whiteboard. If and only if b to the x is equal to y. So now we're going the other direction. Instead of going from logarithmic to exponential, we're going from exponential back to logarithmic. So we're going to start off with log. Base, what?
Log is 5.
Log base 5 of.
25.
Now you can put parentheses around the number inside the log. And on some of them, especially if we have more than one or we have stuff being added or subtracted, we'll need to put parentheses around it. But we get this here. Now we can look at the next one. Log base 10 of is equal to, and that's it. Now we do have something called common logs. A common log has a base of 10. So for this last one here, if it has a base 10, we don't necessarily have to write it. We can just say log of 0.1 is equal to -1. Because it is a common log, it's understood. Like with a square root, we don't have to put the index of 2 because it's understood to be a square root.
Are you going to count us off?
Yeah. So log base 10 of 0.1 and log of 0.1 are the same thing. Now it only works with 10. So with the previous one, log base 5, we have to write it as log base 5 because we need it there. Now it is kind of helpful because the log button on either calculator, there is one that is log, but that is with base 10. So if we said this of 0.1, we would indeed get -1. Now, like the previous one, we had log base 5 of 25. If I do log of 25, I don't get 2. So it doesn't work the same with that there. Now, I will show you this here with the graphing calculator. If we go, clear all that out. If we go math, you can go up or down, but there is one that says log base. And if we select this here, we can actually put the base and the number inside of it, and it will tell us that it is 2.
So it's less than basically
A little bit, yes. Questions on this here so far? So let's look at the next two. 8 to the 2/3 equals 4. So we'd say what? Log base 8 of. That's it for C. Let's look at part D. Log base 6 of. Yes. That's it. And let's look at these last three here. So the first one, 9 squared equals 81. So log base of is equal to, okay. 20 to the -1 equals 0.05. 16 to the 3/4 equals 8. So log base and last one would be log base 15 of 5. We understand this here. Now it seems a little weird why this is important or kind of why doing this is helpful. And it's all dealing mainly kind of with exponentials. So if I said 2 to the x is equal to 8. So, right, 2 times itself, how many times is 8? Because we 2 to the 4th is? Because 2 to the 3rd is 8, so here the value of x is 3. If we said 3 to what power is 9, x would be 2, yes? Because these we can figure out. They're not bad. If I said 3 to what power is 10, is there a number, a nice number we can use here? Well, no. So let's rewrite it as a logarithm. So it'd be log base what? Of is equal to. So now I have a way to actually solve this. Now we could do this in a calculator. I can say math log base 3 of 10 is 2.9. Now if I go 3 to this here, now since we had to approximate it because it's not the full decimal, it does give us approximately 10. But if we did 3 to this time instead of getting that, I'm going to get this, we will get 10. So it is a way to solve these exponentials when we don't have them to where they have a nice number. Questions on any of this here? You ready for the next part? So log base b of 1 is 0. And this is kind of a rule that is very nice to know. Log base, no matter what the base is, if the number inside the logarithm is 1, it's going to equal 0. Because if we rewrote it as an exponential, we're saying whatever the base is to the 0 equals 1. Doesn't really matter what it is. The base to the 0 power will always be 1, except if b is equal to 0. So here, this is true, but we do have to say b cannot be 0, because 0 to the 0 power is not 1. Now also, log base b of b to b is equal to 1, because we're really saying b to the first power is equal to b. So if the base and what's inside of them are the same, they simplify to 1. Does that make sense? Now, probably at this point, you've already plugged some of these in. Now, for log base 4 of 64, we can grab the calculator and say, well, I'll go on and just type it in. We can go math and down to log base 4 of 64 is 3. Okay. Now, there's a reason for this. Part of the reason for this is actually 64 is 4 to the 3rd. And we'll get into this some more tomorrow, especially when we talk about 6.5, properties of logarithms. The exponent property says I can bring this to the front, telling us that we have 3 log base 4 of 4. Now, as we said up here, log base b of b, we have that here, log base 4 of 4 is 1. So we're really saying we have 3 times 1, which is 3. And that's kind of it. And we'll get more into those exponential properties. There are properties with multiplication and division inside the logs that help us solve. But tomorrow when we're going over that, or kind of you all are watching the video, because unfortunately I won't be here for that, I just want you to mainly get an understanding for it. You don't have to completely understand it inside and out, but just get an understanding of how the properties work. Okay? So especially with expanding and condensing, it is not going to be tested too heavily or really at all on the test. Just pulling it together and putting it apart. It'll make more sense when you see it. But we can do the same with the rest of them. Because I could type this in, and we'd get -1. And kind of the reason for that is because 0.2 is the same as 1/5. And if we move the 5 up to the numerator, we get log base 5 of 5 to the -1, which will simplify to -1. Yeah, 0.5 or 1/2. we feel kind of comfortable typing these in. Now we will get a way to be able to type them into the yellow calculator because the 30XS, the yellow ones, do not do log base. There is a way to do it with those, but we have to do something called the change of base formula to be able to type those in. I think this is 4. 4, -1, -3, 1/2. Well, 27 is 3 to the third, yes? It's 3 cubed. 3 times 3 is 9 times, and 9 times 3 is 27. And since we're going from the denominator to the numerator, going from a fraction to a whole number, it has to be negative. But that's, again, just seeing how exponents work. But questions on these here? Because, and again, since we lost 5 days with the snow days, normally if I had the time, this is actually 2 lessons to really break down and look deeper into it. So especially with what we just had here. Yeah. Those 2 little dots were a fly. I would go more into exactly how we break it down and looking at how that all works together. But here we're looking more just kind of plugging them in. Now, this one here, natural logs. These are the other type of logarithmic functions that we'll look at. They're essentially the same thing as our log, except the base is understood to be e, our irrational number, our non-repeating, non-terminating decimal. Now, just like with the log base 10, where we don't have to write the 10, here we don't have to write the e, but the property still holds true, that the natural log of x equals y if and only if e to the y is equal to x. So let's look at this first one here. Now once we see this, it'll start making sense. Now for the first one, I'm going to go on and write e here. So our base, ln of 6, ln base e of 6 is equal to x. So our base is e. So we'd have e to what? X. E to the x is equal to 6. Because it works the exact same as our logs, because we move the number up top and set it equal to 6. And that's it. Let's look at the next one. Ln, the natural log of 5a is equal to b. So our e, okay, e to the b equals 5a. That's it. Questions on this here? This. Now, if you notice with this here, in most all the ones that you'll come across, especially with natural logs, they're going to use a variable in some way, shape, or form. Because if you notice with the logarithms, we had nice numbers, because the first one we did was log base 2 of 16 equals 4. Gave us 2 to the 4th equals 16. It works nice, because 2 to the 4th is indeed 16. Now, if we looked at this here, e to the 6 equals z, I can type that into the calculator. So to get e, we do second ln 6 is this here. But again, e is a non-repeating, non-terminating decimal. So there's no way for us to actually write out what the exact value of e to the 6 is without approximating. So with a lot of the ln switching between the two, we're going to use variables so that we can actually have a true statement and not have an approximation. But questions on these here? So we have the natural log of y is equal to, and that's it. So y is going inside the log. Yeah, this one here, I still find it, I should have probably started with a different one first, because we're using x and y, and in the general form we're using x and y. So that's all we have, ln of y equals 2x. If we look at the next one, we'd have the natural log of, yes. Questions on either one of these here? Ln of 6 equals 9y. And lastly, ln of 4 is equal to b, so it's the natural log. Now, I still find it interesting that it's ln, not nl, natural log. Log natural, because logarithms is still log, the first three letters, but natural log, they flipped it. Don't know. Never looked into why, but I always found it strange. All right. Evaluate log of 8 and the natural log of 0.3. Well, log of 8 here, this is what we would call a common log because the base is 10. So if I want to put this in the calculator, I could use either one because we can just use the log button and say 8, 0.903 because we're going to 3 decimal places. That's it. Now if we did ln of 0.03 or 0, ln of 0.3, there's 204. Questions on this one here? We feel comfortable with these, typing them in, especially if it's just ln or log base 10, just log. These are nice because we don't have a base to put with it. Any questions over these here? And I think we feel comfortable with these, yes? Inverse property, and this is something that is nice to know. The log base b of b to the x is x. If the base and what's inside are the same, it simplifies to just x. Now we saw this earlier with when we had log base 4 of 4 to the third was 3, because in this case x is R3, and the b in both cases here is 4 and 4. Now we also have it going the other direction. B to the log base b of x is indeed x. Questions on this here? This kind of makes sense, yes? Now, I'm going to use this here, and let's start off with log base b of y is equal to x. Now, according to this here, if I put this side to the base, so I do b to the log base b of y. Well, what this property is telling me is that this here is going to simplify out, leaving me with y by itself. But if I do something to one side, I've got to do it to the, so I've got to apply the base b to the other side, giving me b to the x, yes? Well, the statement we started the lesson off with was what? Log base b of y equals x, if and only if b to the x is equal to y. Is that what we got? Yes. Now, I didn't do this in the other hours. I'm going all the way back to the start. Here, we have log base 2 of 16 equals 4, yes? So this time, instead of just just using b, I'm going to put both sides to the base of 2. So this is the same thing that we had. B to the log base b, yes? 2 to the log base 2 is saying that this should simplify and leave us with 16 is equal to 2 to the, isn't that what we got originally? This is why it works. This is why we can switch it. So, the switch. So it's the same thing we did before, where we rewrote it, where we said this here, 4 to the 0 is equal to 1. So really what we're doing is applying a base of 4 to both. So the one side would be 4 to the 0, which we have here. The other side, this is going to cancel, leaving us with.
Okay. Oh. Okay.
So it's the exact same thing. This is kind of the mathematical step we're doing to go from here to here, as we're applying that base 4, base 2.
So what it does is
The exponential, yeah. So does that kind of make sense of how this works? Now, it is also true going the other way. Because here, 5 squared equals 25. If I apply log base 5 to both sides, here, the base and what's inside are the same, yes? So they cancel out, leaving us with 2 is equal to log base 5 of. So the same thing we did before, where we're going back from exponential to logarithm. Log base 2 of 25 is equal to 2. Same thing. So this kind of makes sense how that works. And we'll start using this kind of property more when we start solving. And it'll make even more sense, especially when we start looking at the exponential properties tomorrow and how they work. So, if we look at the first part here, 10 to the log of 4. Well, they didn't write it in, but since it is a common log, the base is understood to be 10. Well, this base and the base for the log are the same, yes? So they simplify out, leaving us with 4. Now the other one's wanting to use our log base b of b to the x. We want the number inside the log to be the same as the base. But luckily for us, we can rewrite 25 as 5 to a power. 5 to what power? 5 to the second, 5 squared is 25, yes? Now we'll do one step more before we finally simplify it. Because powers of powers multiply, so 2 to the x is going to be 2x. So how would log base 5 of 5 to the 2x simplify? It would simplify 2. 2x, because log base 5 of 5 simplifies out. It cancels out and leaves us with just the exponent. Yeah. And it does work that math log base 5 of 25 is indeed 2. We could add the x to it. Any questions on this here? Now we'll look at a few more of these here so we can kind of see how this works. Simplify log, or 10 to the log 18. Yep. Because since the base is 10, so we have 10 to the log base 10 of 18. And since there's not a variable in sight with this one, 10 to the log of 18 is 18. Now it's going to be nice to rewrite 16 as 4 to a power.
Oh, yeah, that's, yeah.
4 to the 4th would be 16 squared. That's good. My head's telling me it's 256. I don't. Okay. So we get this here, which is really telling us that we have log base 4 of 4 to the 2x, which would be
2x.
It's not going to always work out to be 2x, but these last two here have worked out to be 2x. Questions on any of these here? Yes.
So, after we subtract the log to the base of 4, when we do our parentheses, do we just, with our log base, do we just try to find a number that multiplies to the number that it equals, so like the 16?
We're just trying to get these two to be the same, the base and the number inside.
Oh, okay.
And it's going off the fact that log base b of b to the x is x when these two match up. We need them to be the same. Because we could have turned 16 into 2 to the 4th, but that wouldn't help us because the base and what's inside are not the same. Yeah. Now, if we look at these here, 8 to the log base 8 of x. These two here are so they would simplify out, leaving us with x. Yes.
So, and then 14, they would mark out to be left with x.
Yes. Since the base and what's inside it are the same, it would leave us with negative 3x. Now here, unlike the last one, we don't have the base and what's inside it the same. So it'd be nice if I could rewrite 64 as 2 to a power. So 2 to the 8th is 2 to the 6th is 64. So really we're saying that we have log base 2 of 2 to the 6x, which is Now the question is e to the ln of 20. What would this be? Well, what's the base of ln? So ln, because log, if it doesn't have a base, is 10. But e was different. What was it? Or not e, ln's was different. Its base is actually, well, I just said it, e. ln's base is e. So e to the ln, base e of 20. Our answer would be 20. And with this one here, we could have plugged it in. We can say e to the ln of 20 is 20. Then, yeah, luckily with e, it already gives you the exponent. 20. And it works out the other way. I didn't show this earlier. If we did ln of e It actually works out to be 1. The way I kind of remember this, if I have ln of e, it is 1. But that's it there. Any questions on anything we've done so far? Now the last thing we're going to look at is this here, inverses. Find the inverse of each function. Now there are 4 questions of this on the homework. They are bonus. I'm making these bonus points on the homework, so if you do them, you do get a bonus point apiece for each one you do get correct. Now if we want to find the inverse, it's similar to what we've done before. Our first step in finding the inverse is to switch f of x with y. Switch f of x with y. Now the next step is to switch x and y. Right, now we need to get y by itself. Now normally we would divide, especially if it was 6y, but y is now in an exponent. Well, then we'd have the yth root of x, which is a little funky. We're going to use logarithms. So if we rewrote this as a log, it would be log base what? 6 of, it would be x, yeah. So it's just using what we did at the start to get our function. So any questions on A? Let's look at B. Now, they didn't write it as f of x, they already have it as y. So we don't have to rewrite it. We just need to flip x and y. So we have x is equal to ln of y plus 3. Now we do have the ln, so we want to rewrite this one as an exponential. So the base is understood to be e. So we'd have e to the what? X is equal to y plus 3. Is y by itself? Now in the previous one it was, but this one here we have 2, 3 minus y is equal to e to the x minus 3. And that's it. So I went on and gave you the other 2. But questions on these here? But that is it with this here. And that's all we're covering. Yes.